Welcome to Study Loop.
In this problem, we have an electromagnetic wave of frequency 7.14 times 10 to the power of negative 14 hertz. And what we want to know is what is the corresponding wavelength of this electromagnetic wave and how is it classified based on that wavelength. So the equation we should use is speed of light c is equal to the wavelength lambda times the frequency f. In general, for any type of wave, we would say that the velocity of propagation is equal to its wavelength times its frequency. But in this case, because we're dealing with an electromagnetic wave, we know that it's traveling at speed of light c. So we plug that in rather than some other velocity. All we need to do now is rearrange this to isolate for our wavelength. And you can see that that should be speed of light divided by frequency. And then we can just plug that in. So we know speed of light is 3 times 10 to the power of 8 meters per second. And we're given that our frequency is 7.14 times 10 to the power of negative 14 hertz. And if you plug this into your calculator, you'll find that it's equal to about 4.2 times 10 to the power of negative 7 meters. So that's your wavelength. That's the first thing you're asked for. And then what we need to do now is just look at a chart of the different wavelengths and frequencies and in the way that they're classified. So either look one up online or in your textbook, search for one. And you should find that the visible light range is somewhere between 7.5 times 10 to the power of negative 7 meters and 4 times 10 to the power of negative 7 meters. Oops, I've drawn these the wrong way. And our 4.2 falls nicely within this range, so this wave is within the visible light spectrum. And that's your answer.